Okay, this is a problem or a truss which is statically determinate. We can find out the indeterminacy or degree of indeterminacy by applying the formula as n plus r minus 2j. Number of member is 1, 2, 3, 4, 5, 6. Okay. If this joint is not named in the question, then this cannot be considered as a joint. Okay. Plus r, number of reaction is 2 plus 1, 3. Okay, 9 minus 2 into joint 1, 2, 3, 4. So 2 into 4 is 1. Okay, so now we can apply second theorem of Castigliano to find out the redundant member. So you can consider any member as redundant. Okay, so I am considering the redundant member as BD. Okay, so BD is a redundant member. So the first thing is we have to divide it into two equal parts. Okay, so if I divide it into two equal parts, so what will be those forms? So this will be a truss without BD, only AC will be there, A, C, B, D, and a load is applied 60 kilonewton. This one is hinged and this one is a roller. And now this is a statically determinate truss. Okay, we can find out the member forces very easily. Okay, what will be the second part? Instead of the redundant member, we are going to apply a unit force of 1 in that place. How? This is hinged and this is a roller. Okay, now this one is A, this one is B, C, D. All the external loading systems will be removed, and instead of the redundant member, one unit force at this member will be applied. Okay, this the direction of this unit force can be anything. I am taking as tensile, you can take it as compressive. This is not going to affect the final result. Okay, so now we have to find out the member forces. So here the member forces will be, this one will be P A B, this one is P B C, P C D, P A D, and this one is P A C. This one will be K A B, this one will be K B C, this one is K C D, this one is K A D. Okay, and there will be another AC. I forgot to draw this. This one will be K A C. Okay, now we need to find out all these member forces by a composition and resolution method. Okay, now if we solve this, we will get the values as I will write them. So in this truss, this PAB and PBC will become 0 because at a point both two forces are applied, two members are connected. However, there is no other support reaction or external loading, so these two forces becomes 0. Now to find out the other member forces, we need to find out this support reaction, vertical reaction at D, horizontal reaction at D, which is hinge support, and roller support reaction is VC. Okay, to find out them, we have to go for or applying equilibrium equations. Okay, now if I apply equilibrium equation, let's take moment at point D is equals to 0. So if moment at point D is 0, the external loading is VC and it is 60. So I can write as VC into this length is given as 4. So this is anti-clockwise direction. This load is making clockwise direction. So this is 60 into the length is 5. So we will get VC as 75 kilonewton. Okay, so we are VC 75 positive, so our taken direction is okay. So now we need to find out VD as VD plus VC, summation of vertical force equals to 0 is equals to 0. Okay, so there is no vertical force, so from this we will get VD is equals to minus 75 kilonewton. So direction is downward. Okay, now we have remain HD. Taking horizontal, this is summation of vertical force equals to 0, summation of horizontal force अगर 0 करूँ, then we'll get HD is equals to minus 60 kilonewton. If it is negative, then taken direction is wrong. Okay, now this is our direction. Okay, now if we solve by taking joints and applying composition resolution technique, so if I take joint C, if I take joint C, this is one member force, this is one member force, already 0, this is one member force, and VC is applied. So if I draw a free body diagram, we can draw this as in this direction VC, which is 75, okay, and PBC in this direction, which is PBC, which is already equals to 0. PCD is acting this way, okay, and PAC, there will be two components, along this direction one, along this direction one. So we need to find out this angle also. Let's consider this angle is theta. Okay, so if this is theta, then what will be tan theta? Tan theta will be equals to 5 by 4. Okay, sin theta will be equals to 5 by root 41, and cos theta will be equals to 4 by root 41. Okay, so by applying Pythagoras theorem, we are getting this value as 15 root 41. Okay, so now if we resolve PAC along this direction, PAC sin theta, along this direction PAC cos theta. Okay, upon solving or applying vertical force equals to 0 and horizontal force equals to 0, we'll get PCA. We're getting PCA or PAC is equals to 15 root 41 kilonewton, which is negative in nature, that means compressive. Okay, and we are getting PCD will get as 60 kilonewton, which is tensile in nature. Okay, now by considering joint C, we got this. Again, if you consider joint D, there are only two forces, one is PCD and HD in the same direction. Along this direction PAD and VD. The only unknown we have now is PAD. So PAD is along this direction, and VD, which is minus 75, acting downward. Okay, so by taking joint D, if we take joint D, we can get the value of PAD. So PAD will be equals to 75. Okay, 75 kilonewton, which is will come tensile in nature. Okay, so we now got all the member forces. Where are they? PAB is 0, PBC is 0, PAC, CD and PAD, all the 5 member forces. Now we need to find out all the member forces for this condition. So for this condition, as there is no external loading, so the reaction here will obviously become 0. Okay, now there are no reactions, only there is one unit force 1 and there is one unit force 1. So now here again we have to take different joints. Okay, let's consider joint DCB. It's your wish. We need to find out the member forces by drawing free body diagrams. Okay, so if we solve it, we'll get by taking joint D. If we consider joint D, then we'll get KCD is equals to 1 cos theta. So this will be 4 by root over of 41 kilonewton negative, which is compressive in nature. Okay, so by taking joint D, we got KCD and we'll get KAD also. We'll get KAD as 5 by root 41, again minus, this will be again compressive in nature. Okay, similarly consider joint B. If we consider joint B, we will get K. Considering joint B, we will get KBC. KBC will get 5 by root 41 kilonewton, which will be again negative, compressive in nature. Similarly, we will get KAB also compressive in nature, which is minus 4 by root 41 kilonewton, which is compressive in nature. Okay, the remaining, what are the remaining? KAC. We'll again take joint A. By taking joint A, we will get KAC sin theta equals to 5 by root 41. So we'll get KAC as 1 kilonewton, which is tensile in nature. Okay, what will be the value of KBD? KBD will also become 1, as we have taken 1 in this instead of the term BD, 1 kilonewton. Okay, we have taken tensile, so let it be tensile. अगर compressive लेते तो यहाँ पे -1 होता, and accordingly all the values would have been changed. Okay, so now we got all the member forces for both the conditions. Now for the question, if we need to find out the values of actual member forces, which is S or SAB, we can write this as PAB plus the redundant X into KAB. Similarly, SBC will be equals to PBC plus X into KBC, and this goes on. So the only unknown now we need to find out is X. Okay, so we have to apply the formula now to find out the redundant member. What is the formula? X is equals to minus summation of P K L divided by A. As modulus of elasticity is constant for all the members, it will be cancelled out. So divided by summation of K square L divided by A. So we have to do one table. Okay, so the first one is member. Which member? Okay, then it is coming the P force, then K force, then length, then cross sectional area, then PKL by A, and the last one is K square L by A. Okay, so we need to find out the values for each member. Okay, so first is, let's consider member AB. For member AB, we have already found out what are the member forces. What is PAB? We have got 0. Okay, similarly K for AB, how much we have got? Negative -441, -4 divided by root 41. Length of member AB, how much it was written? It was 4. So let's write 4000 mm. Area, cross sectional area. So in this question, it is given already, I forgot to tell you, the value represented in the bracket represents the cross sectional area of each member. So these two members have cross sectional area of 900, these two have 1200, and these two have 1500. Okay, so for member AB, the cross sectional area is 900, so let's write 900. Okay, so we can find out this value now, PKL by A. So this will become 0, obviously, because this term is 0. If we multiply K square by L, then we'll get the value of 1.73. Calculation part you can do. Okay, similarly for member BC, again the force is 0. This value is -5 root over of 41. Cross section, length is 5000, and the cross sectional area we have 1200. This term will become 0, and we'll get this term as 2.5. Similarly for member CD, for member DA, for member AC, and for member BD, we have to do it. Okay, so if you do the calculation, you will get the values like this. Then we have to find out the total value of this. This one is summation of PKL by A, will get -820.6, and this one will get 17.08. Okay, so now we can find out the redundant unknown X is equals to minus of -820.6 divided by 17.08. So we'll get it as 48.02. Okay, now we need to find out the actual member forces. Which one is SAB? SAB will be equals to PAB plus X into K AB, we have all the values, isn't it? PAB, how much? 0, plus X value is 48.02 into KAB is minus 4 by root over of 41. Okay, upon calculation we'll get this as 30 kilonewton, which is negative in nature. Okay, so this will be compressive in nature. Okay, similarly we have to find out the member forces SBC, which is equals to PBC plus X into KBC. PBC is also 0 plus KBC is 48.02 into KBC is minus 5 by root over of 41. So we will get this as minus 37.5 kilonewton, which is again compressive in nature. Okay, similarly SCD, and all the values will get how much? PCD is 60, okay, plus X is 48.02 into KCD is minus 4 by root over of 41. Okay, so we'll get this as again minus, this one is, we'll get plus, okay, 30 kilonewton, which will be tensile in nature. Okay, similarly SDA 75 plus 48.02 into minus 5 by root over of 41. So we'll get 37.5 kilonewton positive. So this will be tensile in nature. Okay, similarly SAC will be minus 15 root over 41 plus 48.02 into 1. Okay, so this will get minus 48.02 kilonewton, which is compressive in nature. Okay, last one is SBD, which is the redundant member we had considered. PBD is 0 plus 48.02 into 1. Okay, so this will be 48.02 kilonewton, which is tensile in nature. Okay, so we got all the member forces, actual member forces in this structure. Okay, now similarly you can solve other problems in the book Ramamrutham. Okay, I will give you the questions, you solve them.